Good afternoon, everybody. Welcome to a wonderful afternoon of Chem 170 with your host, me, Dr. White. I hope you all had a good time since we last met. All right, we got a lot to do today, but let me remind you, on Wednesday at the beginning of class, I will be going through what I call the method. I haven't come up with a better name. I did, but it didn't stick. And that's a method that eliminates test anxiety. And it's helped a lot of students over the years. I've been doing it. And I've actually taught it to people as young as when I was requested to help someone 10 years old, and it made a big difference. So I'll do that on Wednesday at the beginning of our meeting. Now I'll cut it out of video, but what I will do, if you can't make it, I'll set it up as a private YouTube video where nobody else can see it, but anybody who I send the link to. And then at a later date, I'll just delete it. Someday, maybe I'll be able to sell it. That's why I'm just not keeping it on the video. By the way, how many of you give me a thumbs up found the video useful? Thank you. I guess I better do it. If you're finding it useful, I am. All right, let's get to work. Now, last week, I started your journey into my world, which by the end of the semester, you'll find out is really your world of organic chemistry. Now, one of the things I like to do is go back and do a little review. And we talked about how to draw organic molecules. Remember, when we're talking about saturated hydrocarbons. Remember, a hydrocarbon is a molecule with only carbon-hydrogen atoms, which all carbon-carbon single bond, or carbon-carbon bonds are single bonds. And we also will get into later on unsaturated hydrocarbons, molecules with only carbon-hydrogen atoms, that's a hydrocarbon, that contain one or more carbon-carbon multiple bond, meaning a double and triple bond. And we'll talk more about that. And next, I talked about the alkanes. And for this slide, remember the switch was off. The switch, when I do this, is will it be on a test? No, but it's terminology I will use, and you should know what it means. All right, remember, an alkane is acyclic saturated hydrocarbon. Cyclic means ring. The prefix A means without a ring. Ooh, time for a show and tell. So if I have a model like this, the center of each one is a carbon. There's only carbon-carbon single bonds. The line or two between the two, once a double bond, there'd be two bonds or two tubes, or triple bond, three. Now, this is acyclic. If I connect the ends together, I have a ring. Good news, you don't have to use models. When I was an undergrad, taking organic chemistry for chem majors, you have to buy your own bottles and bring them to test because you use them. Relax, you don't have to do that in my class. All right, so we have an acyclic saturated hydrocarbon alkane. And if it's examples here are methane, ethane, and oh, it's your old friend propane. Everybody remember that? CH3, CH2, CH3, propane. And then there's cycloalkanes, like I just showed you, which are saturated hydrocarbons where they're in a cycle, which we call a ring. And I happen to notice, like this one, it's not flat like a piece of paper, even though you draw it that way. All right, now, Again, I'm doing a little review of what we did last Wednesday because it's important to make sure you're up to speed. I want you to do well. And here, condensed structures. That's where you show the atoms, but you don't show each individual carbon hydrogen bond. So if we were to have propane, which is C3H8, has 3 carbons. And remember, and this is going to be your friend, how many bonds to carbon are there? 4. Like I got that finger fixed. 4. How many bonds to carbon? 4. If we were in a classroom now, I'd say, class, everybody, how many bonds to carbon? And you'd all say 4. And if you didn't do it loud enough, I say, oh, come on, fire up. How many bonds to carbon? 4. 4. By the way, I'm ambidextrous. I can even do this with my eyes closed. It was bad humor Monday. But seriously, your friend this semester that will help you on every test and a final is how many bonds to carbon? 4. And now we have to do some, pick up my pen that I just dropped. That's the first time I ever did that this semester or any semester. All right, so this carbon right here has 1 bond, but there should be 4. 4 minus 1 equals 3. So to get the 4 bonds, whatever is missing, you replace with hydrogens. Now this carbon has how many bonds to it? 1, 2. And all carbon should have 4 bonds to carbon. 4 minus 2 equals 2. So to make up the remaining bonds, I put 2 hydrogens. And this last carbon, how many bonds does it have? 1. But carbon should always have 4 bonds to carbon. And 4 minus 1 is 3. Now rewrite it so it looks nicer. And that's how you do it. Did I tell you I like to, oh, before I even say that, important reminder. Remember, in my class, in my world, there's no such thing as a dumb question. I'll say that again. In my class, in my world, there's no such thing as a dumb question. Always, always feel free to ask questions, whether it's in class by turning on your microphone, whether it's using the chat. Once in a while, I forget to look down and see if there are any chat messages for me. That's the bad thing about Dr. White, bad Dr. White. Everybody know what this means? Shame, shame. I had a student 2 semesters ago who was not from America originally and have never seen that. So I taught her. But anyways, that's how you do it. So always feel free to ask questions. You can also email me or come to my office hours. Now, I like to share the fun because I don't want to keep all the fun to myself. So it's time for you to have some fun. For this molecule, put in the hydrogens. Your turn. See, I share the fun. And it's permitted to smile while you're having fun in my class. And I'd like to thank everybody who's got their webcam on. It feels so much nicer to see real people instead of just names. And if you finish early, please be patient. I try and give everybody time to finish. Remember, 4 bonds to carbon. Isn't the math hard in my class? And the reason why this is an important exercise is on my test and in general in organic chemistry, you have to write down or draw molecules. And that includes putting in the hydrogens. Anything else that's needed too. Now, one of the things I did earlier is I set up a poll. Are you done? Oh, it works. All right, I think everybody's done, so it's my turn. Let's do this. This carbon, the first one right here, has one bond to it. There should always be 4 bonds. 4 minus 1 is 3. So it will have 3 hydrogens. Same here. This carbon has 1 bond. And carbon should always have 4 bonds. 4 bonds to carbon. And 4 minus 1 is 3. Now, same thing with this carbon. It has 1 bond. Carbon should always have 4 bonds. 4 minus 1 is 3. Here's another one. This carbon has 1 bond. Carbon should always have 4 bonds. 4 minus 1 is 3. And this last carbon over here also has 1 bond. And carbon should always have 4 bonds. 4 minus 1 is 3. Everybody on board how I got those carbons? If not, ask. Remember, there's no such thing as a dumb question. And you people are all learning this for the first time. Let me clean this up a little. All right, we've got 3 more carbons to go. Let's look at this carbon. How many bonds are there? Count the lines. 1, 2, 3 are adjacent carbons. There are 4 bonds to that carbon, but 3 bonds to that carbon. Carbon should always have 4 bonds to carbon. And therefore, 4 minus 3, math is hard, is 1. So I'll put a hydrogen there. Let's look at this carbon. How many bonds are there? 1, 2, 3, 4. Ooh, remember, carbon should always have 4 bonds to carbon. 4 minus 4 is 0. Therefore, I don't have to put any hydrogens there. And finally, the last carbon here. How many bonds to that? 1, 2. Carbon should always have 4 bonds to it. Remember, that's going to be your friend. There's always 4 bonds to carbon. And 4 minus 2 equals 2. And that's how you put it into hydrogens. Remember, your friend will always be how many bonds to carbon? 4. And in a couple of weeks, hopefully none of you are having nightmares seeing in your dreams how many bonds to carbon. But seriously, that's important. By the way, if anybody finds an example where you have more than 4 bonds to carbon, let me know, and we'll be rich beyond our wildest dreams. And that goes beyond me having my own island in the South Pacific, my own Lamborghini, my own Ferrari, and my own fighter jet to play with. Goes beyond that. In other words, it doesn't exist. All right, let's get on to some new stuff. Let me get to the right slide. All right. Remember, everything you see here is available to you on Blackboard. This file, secretly named Chapter 2 Alkanes, is in Blackboard in the lecture section. All right, I showed you cycloalkanes, and we'll do that later on. We've done that. By the way, isomers, I was watching cable the other day, and this company is still out there selling stuff at outrageous prices for what they're doing, which is probably why they're making a lot of money. And the company Isomers sells personal care, really cosmetics, which is a very lucrative side of organic chemistry, not only Isomers, other companies. All right, now here's where we ended up just about. We're talking about nomenclature. Nomenclature is a fancy word meaning it's a name. And back about 1900, the countries of the world realized with the expanse of the knowledge of chemistry that was going on then and the coming years, it's important to know what the correct name of a chemical is, a molecule. And the bulk of those are organic molecules. So they created an organization by a treaty, which the United States signed, called IUPAC. I will never ask on a test, what does IUPAC stand for, even though I think it's cool to say, but I'm an organic chemist, so that's why I think it's cool to say International Union Pure Applied Chemistry. This is the organization that created the rules that we use to this day for naming any organic molecule. And the beauty, and I mean it sincerely, is that IUPAC has done such a wonderful job that I have never heard an exception. If you have a compound and you name it correctly by the IUPAC rules, there's only one name you can come up with. Again, if you name it correctly, there's only one name you can come up with. And if you have a name, there's only one structure that you can draw. And that's a tremendous feat what they did. Quick personal note, a number of years ago, one of my patents, I invented a couple of new molecules, 4 of them, and I wasn't sure what the IUPAC name was. And some of the colleagues at my company I worked at, we disagreed. And the lawyer, because it was going to be in a patent of mine, we need the correct name. We sent the structures to IUPAC in Geneva, Switzerland. Back then, I don't know what they charge now. They charged $1,000 a compound to give the correct. And surprisingly, it took them about a month, and they apologized because they weren't sure until they finally figured it out. I was part right, and some of my colleagues were part right, meaning we were also part wrong. But once that, and the only bad thing about that, sad thing, the company wouldn't let me keep the certificate. I never photocopied it, I should have. But anyways, now, when it comes to nomenclature, here I have this table, but a better table, this is if you had gotten the book, which you don't need, a better table is this right here. The alkane names, IUPAC names, whenever you see the term IUPAC, for you, you should know that's the official name. So if you have a alkane, remember that's an acyclic, not in a ring, hydrocarbon, saturated hydrocarbon. 1 carbon is called methane. 3 carbons, oh, it's your old friend propane. 4 carbons is butane. 5 is pentane, 6 hexane, heptane, 8 octane. Where have I seen that before? How many of you have seen the octane number on a gas pump? You know, when you get the different grades of gasoline, you can see the octane number underneath it, and that comes from having octane or isomers of octane in the gasoline. Ooh, time for a public service question from Dr. White. How many of you, when you drove by a gas station, and give me a thumbs up, thought about half the weight of the gasoline they're selling are alkanes? All right. Remember, it won't hurt for you to think about organic chemistry when you're not in my class or lecture or lab. It's all around us. It's everywhere. I stole that from SpongeBob. So I got the whole semester to work on you all to think about different things you see in your daily life or organic chemistry. I'll get to you. I don't give up easily. All right. Now, this chart, and I'm going to be very honest with you right now. If you don't know this chart, you're going to lose 50 points on test 1. If you don't know this chart by heart, you're going to lose about 38, 40 points on test 2 and 3, and about 40% of the points on the final, plus on test 4. Now, I write my tests in such a way, I know people are cheating. I've been doing Zoom long enough and I can do that. Unfortunately, it works. So you need to memorize this. How do you memorize this chart? Well, let's take butane. To memorize the chart, and you have to do this yourself. I already know this if you haven't figured that out. Say butane, write it down, and 4 carbons. And then say it again, butane, and write it down, 4 carbons. And do it 5 times. And then do it another time, a couple more times. And let's do it a couple more. Butane, 4 carbons. If you want to write out carbons, you can. And don't use quote underneath to repeat. Actually say it, butane, 4 carbons. Butane, 4 carbons. And by doing this and doing it a second time, it will burn it into your brain. By the way, if you haven't thought about it, have you ever seen those small gas lighters called butane lighters? The liquid in there is butane. Now, one of the type of questions I can ask on a test. So the question is 3 points each, and I do not do multiple choice questions ever in Chem 170. Never have, never will. But I do small questions where you have to write in the answer. And here, draw the structure for butane, 3 points each. So how do you do that? Well, first of all, you have memorized this chart. Hint, oh, I better be really subtle. Subtle. And you look and you memorize butane has how many carbons? 4. So we now know butane, which is an alkane. Oops, wrong color. Right color. Hold on. There we go. Has 4 carbons. And now you have to put in the hydrogens. You know something? I'm going to let you put in the hydrogens than I will. Why don't you put in the hydrogens for butane? Remember, there's 4 bonds to carbon. Now, right now, maybe a little challenging. In about 4 weeks, you'll look back and wonder, why did I have trouble with this? Well, or why was it difficult at first? Well, it's new. We're in class, which unfortunately we're not, or fortunately. I'd say when you're done, look up and smile. I see a lot of smiling faces in my class, but I'll do this. Oh, it's untitled. I thought I had a title. I'll change that later on. All right, I think everybody's done. So if we look at the first carbon, there's one bond to it. Carbon should always have 4 bonds to carbon. 4 minus 1 is 3. Second carbon here has 2 bonds. There should always be 4 bonds to carbon. 4 minus 2 is 2. The same next carbon has 2 bonds to it, run here and here. So same thing. Carbon should always have 4 bonds to it. 4 minus 2 is 2. And this last carbon has 1 bond to it. Carbon should always have 4 bonds. 4 minus 1 is 3. And this is what you'd have to write down. Now, if you wrote it this way, without the lines, I like putting the lines in because when my molecules get longer, they start drooping toward the floor. So it does look good. So that's why I put lines in. You can do either one. Now, there's the line method. I've had students in the past, you do not have to do the line method, which would look like this. But if you do that, that's okay. But I'd prefer use this method or this method. Why? Because you can do better. Students make mistakes on the line method that they don't make when they show all the carbon and hydrogens. And it makes me feel better to see students do good on a test and not make mistakes that are unnecessary. All right, now, another type of question using that same table. Give the IUPAC name for, and you're given the structure. So what do? Well, the first thing you look at it and say, well, that's an alkane. It's acyclic. It's got only carbon and hydrogens, and it has only carbon-carbon single bonds. How many carbons are there? Well, let's count. 1, 2, 3, 4, 5. Remember, you have to know how to, this part of the semester, count up to 10. And if I have 5 carbon alkane, what's its IUPAC name? Well, once again, you've learned this chart. And 5 carbons is pentane. So the answer for that question would be pentane. And that's how you get your 3 points. So if you don't know that table, either of these type of questions, you don't know how to do. Now, these type of questions I call nomenclature questions. Nomenclature questions are questions that test your skill of naming compounds. And that's an important part of organic chemistry. However, not the most exciting part. I'm a synthetic organic chemistry, and when you start making things, that's when it gets exciting. But this is very important too. All right, so let's do one more. Or better yet, you do one. All right, the question is, give the IUPAC name for the following molecule. Now, unfortunately, I can't do it on Zoom, but if we were in a classroom, I'd have the following. So what you need to do is first count the carbons, and then I'll open up another table. Hopefully you've all counted the carbons. I'll help you out today, but this is something you have to memorize. It looks like everybody's done. So if we go back here, how many carbons are there? Well, I'm going to count carbons, letter C. 1, 2, 3, 4. You don't count hydrogens. 5, 6, 7, 8. Oh, I should point out something important. This is how I write the number 7, or let me do it better. Back in high school, I had a German teacher, Herr Brink, who was from here, means Mr. Herr Brink came from Germany, great teacher, funny guy too. And he wrote his sevens like that, which is the German or European way. And I thought that was the coolest thing in the world. And I've been doing it ever since. But anyways, this compound has 8 carbons. It's an alkane. If you look at the table, 8 carbons is octane. Therefore, the answer here would be octane. But if you didn't know that chart, you couldn't answer it. So remember, for IUPAC alkanes, you need to count the number of carbon atoms and use that table. Now, let's look at something interesting. Oh, this is all interesting, but I'm biased. One thing I should mention after today, it is your solemn responsibility in my class that when I write a structure like I do, and I'm going at warp speed, you don't know science fiction, you don't know what I just said, meant very quickly, putting in the hydrogens. And if you should always check that there's always 4 bonds to carbon, I don't make a mistake. I don't think I did, but last time I checked, I don't walk on water unless it's frozen. Even then I stay off, which means I'm human. I can make mistakes. All right, let's take a look at this molecule. And the question would be, what's the IUPAC name for the following? Now, if we look at that, we can count carbons across 1, 2, 3, 4, 5, 6, 7, 8, and this one makes 9. However, that's not a straight chain. They're not all straight across. What do I do? Well, good news, IUPAC came up with rules for this. And the first thing you have to do, and relax, at first it seems difficult, but take a deep breath, let it out, take a deep breath, let it out, you'll get it. You find what's the longest chain. Now, the reason we call it a chain is, how many of you have ever seen a bicycle chain, or like the chain I have around my neck for jewelry? And it's the metal circles or loops hooked together, linked together. And organic chemists say carbon 1 is linked or bonded to carbon 2. Carbon 2 is bonded to carbon 3. Carbon 3 is linked to 2 and 4 and also 9, because the line tells you they're linked together. So what you have to find is what's the longest chain that's linked together of carbons. So how do you do that? Well, there's only one way I know. You start counting. Now, if I go straight across, starting here, and going to here, there are 8 carbons connect together in a straight chain. Now, if you've ever seen a bicycle chain, and I don't have one up here with me, it doesn't have to be straight across. Now, let's see if you can see this. See, I have my chain here. Here it's straight across. Now it's not straight across. And therefore, one chain is carbon 1 through 8 straight across. Another chain would be this carbon, this carbon, this carbon. Carbon 3 is linked to this carbon, and that's 4 carbons. But you're trying to find the longest chain. And now you have to, it's getting hard math now, know what numbers are larger and smaller from 1 to 10. Now there's another chain. I can start here, 1. This carbon is bonded to carbon 3, 2, then this one, then this one, this one, this one, and this one. Ooh. So you have 3 possible chains, and you can count the other way and you get the same thing. And the question is, what's the longest chain? And the answer is 8. And as soon as you figure out the longest chain, you name that longest chain as an alkane. And 8 carbons, you've learned this table, hint, know this. By next week, you really should know this by heart. 8 carbons is octane. So the root name for this molecule is octane. And as soon as you write down octane, everything I just circled is spoken for. Are we done? No, there's just 1 carbon left over that we haven't identified. When you have carbons that are off the main chain, or this is called a branch. If you go outside and look at a tree, now I have the main trunk, and then you have branches coming off them. Hold on, this is the age of the internet. All right, everybody see this tree right here? See how you have the main right here? Then you have branches, a lot of branches coming all off. And in organic chemistry, first we find the main branch tree or the trunk. We don't call it a trunk. And then we have to name the branches. Well, how do you name the branches? All right, so what we're doing are the rules here. Listen carefully. I will never ask you what are the rules to name alkanes, but I will ask you to know how to use them. So for alkanes has an ANA ending, and you'll learn more about that later on. Alkanes without branches are named according to carbon atoms, like we just did. Now, alkanes with branches, the root name is that of the longest continuous chain of carbon atoms, which we found out was 8. Now it gets exciting. Groups attached to the main chain are called substituents. I'll never ask you what's the name of groups attached to the main chain. Now, there are different types of substituents, and one that's saturated substituents and that contain only carbon and hydrogen atoms are called the alkyl groups. I'll never ask on a test what's an alkyl group, but I'll use that name a lot in our class. And alkyl groups are named, now here they have a rule, IUPAC has a way of doing it, and I have it here, but what we'll do in this class, and for most of organic chemistry, here I have the alkyl groups. Does everybody see the alkyl groups on the screen right now? Give me a thumbs up if you can see it. Thank you, Jessica, and everybody else who just came after Jessica. All right. Time for me to be subtle. You should know this one. Now, one carbon, CH3, and that line means it's attached to somewhere on a chain, is called a methyl group. One carbon, CH3, attached to a chain, or the longest chain, is a methyl group. And before I go through the rest of this chart, let's go back to our original chart, or molecule. See right here, what do we have? CH3, and that's called a methyl group. And the substituents are put in front of the root name, which we figured out was octane. Now, let me go back to that chart and talk about some other. Now, 2 carbons is ethyl. Now, 3 carbons, you have 2 choices where, by the way, this table, is located in the lecture folder of Blackboard, secretly named key alkyl groups. Now, one thing, Blackboard gets funky when you have so many files in a folder. If you go to the bottom, you may have to click on a button that says see more files. I'm pretty sure for lectures you have to do that. Now, when you have 2 carbons, 3 carbons, you can either have it to the end carbon or to the center carbon. When the end carbon is attached to the longer chain, it's called end propyl. When this substituent, 3 carbons, the center carbon is attached to the longest chain, it's called isopropyl. Anybody ever hear isopropyl alcohol? I wonder where they got the name. We'll learn later on from this. And Dr. White likes isopropyl groups. They've been good to me. I've been good to them. Now, you know I'm an organic chemist. Now, when you have 4 carbons, There are three possibilities. One possibility I have never used and I've never seen used in my professional career. And I worked many decades in the chemical industry. I should have said that. Yep, many decades. But these two you do. When you have 4 carbons, 1, 2, 3, 4, and the end carbon is attached to the longest chain, we call that an N-butyl. When we have 4 carbons and 3 carbons are on a center carbon and it's attached to the longest chain, we call that a tert-butyl. Did I tell you organic chemists are lazy? And when we don't want to say things, and we'll do the easy way, for the first couple of weeks, I'll call it tert-butyl, but organic chemists really call it a T-butyl. In about 2 weeks, I'll get lazy and call it a T-butyl. Tert is short for tertiary 3. And Dr. White loves T-butyl groups, and they love me. I've used both isopropyl and T-butyl in research I did, like for my PhD thesis and other things. Also methyl and ethyl and propyl, not that much, and butyl, not that much. And ethyl has been good to me. So these are the different alkyl groups. And as we'll see later today, you need to know what they are. And again, how do you learn it? On a piece of paper, write down CH3 line, methyl, and say it out loud. On a piece of paper, a second time, CH3, methyl, third, and so on. And you do these all, and it will help you learn them. Plus doing the practice problems. So we now know that's a methyl group, but the question is, where is it? And IUPAC has rules for that. The main chain is numbered in such a way that the first substituent encountered along the chain receives the lowest possible number. Each substituent is located by its name and carbon number, which it's attached to. So let's go back and look at this. I have this chain. Here's my methyl group. What carbon is it on? This carbon. If I start from this end, it's on carbon 3. But if I start from this end, 1, 2, 3, 4, 5, 6, it's on carbon 6. The IUPAC rules are you number from the side that gives the lowest number. So now I got to use your high-level math skills. What's the lower number? 3 or 6? I like my special effects. Oh, that was bad, Joe. Sorry. All right, time's up, and hopefully I'll pick 3. So how do we do this? It's on carbon 3, and between carbon numbers and letters, use a hyphen. And that would be 3-methyl octane. And that's the IUPAC name. So first you find the longest chain. We're going to do more of these today. And we found that was 8 carbons. You looked at the table, 8 carbons is octane. By the way, that's an A, octane. Once we say octane, all the carbons in the circle are spoken for, but we have something left over. This is called an alkyl group of carbon hydrogens. And it has 1 carbon, and from the table of alkyl groups, 1 carbon is called the methyl group. So it's now methyl octane. And finally, you number it. You need to put a number. What address is the alkyl group on? And you number from each end of the chain in such a way that you give the alkyl group the lowest number. And 3 is lower than 6. So it's 3-methyl octane. And that's the IUPAC name. That's a lot of work. I went a whole minute over into our break time. Let's take a 5-minute break. I can get up and stretch. And we will see you at in 5 minutes from now, wherever your clock is. Mine would be 1:56. I'll see you in 5. Time to get going. All right, we're talking about nomenclature, which is the fancy word for naming organic molecules. Now, I'll be very honest, this isn't the most exciting part of organic chemistry, but it's still very important. Think about if you went to a 4-star restaurant and ordered plain white toast and water. Yeah, it'll keep you alive, but there are a lot of better things on the menu. And later on, we're going to get to some of those better things. But for now, this is important. All right, let's go back to how do you name something? And let's do another one. Now, one thing I haven't talked about, that's my 25-second rule. What's that? Well, I'm doing examples on the fly. Once in a while, I'll write an example and say, oh, that doesn't work. And I'll have to do a new one. So give me about 20 seconds or so before you start writing this down. All right, same question. Give the IUPAC name for the following molecule. All right, does everybody see the molecule I just wrote on your screen? And in case you can't count, or it's hard to count at first, 1, 2, 3, 4, 5, 6, 7, 8, 9 across, was down here on this carbon are 2 carbons. All right, there's in teaching, it's called fading prompts, and that's what I'm going to do now. What I'd like you to do, the only thing I'd like you to do is what's the longest chain? That's all I'm going to ask you to find out right now first. What is the longest chain? And again, you're new at this, so if you're having difficulty, that's expected. And there are 3 possible chains you should be looking at. Hint. And a nice thing about having your webcam on, I can see you're still working. So I'll shut up. All right, looks like everybody's done. My turn. All right, question is, in order to name this, and the original question was, what is the IUPAC name? Or I could write, give the IUPAC name for the following. And the question is, first of all, you have to find out what's the longest chain. And 1, 2, 3, 4, 5, 6, 7, 8, 9, if I go across. Is that the only chain? No. I can start here, 1, 2, 3, 4. Now this carbon is bonded to that carbon. It's linked, so it's, even though it's bent, it's part of the chain. 5, 6. Well, 9 is still greater than 6, so I still have to check. There's one more chain. I could count from different ways, but I'll start here. 1, 2, this carbon is bonded to this carbon, so that would be 3, then 4, 5, 6, 7, 8. So you have 3 possible chains. One is 6 carbons, one's 8 carbons, and the last one is 9 carbons. IUPAC rules, you pick the longest chain as your root name. And in this case, hopefully y'all pick 9 is greater than 8 and 6. So the longest chain is 9 carbons. Oops, I just wiped out a carbon. I didn't know I was that powerful. All right, so the longest chain is this. Now, one of the things on a test, you don't have to write the numbers down. You don't have to circle it, but I'm showing you the thought process right now. So now to name this, what's the root name? 9-carbon alkane. And you have learned this table. See, it even says hint, know this. And 9 carbons is nonane. So the root carbon, the name at the end, is nonane. Now, are we done? No. We have this substituent or alkyl group left over. How many carbons are there? 2. And now what we have to do is go to this table, which you also hopefully as soon as possible will memorize and know this, and 2 carbons. 2 carbons is called an ethyl group. Notice I have 2 carbons. This line means it's bonded to something else. That's why this carbon here doesn't have 4 bonds to it with hydrogens, because one of the bonds is going to my chain. 2 carbons is called an ethyl group. So we now know these 2 carbons are ethyl. Am I done? Ooh, time for Dr. White's story. And the answer is no. Years ago, I worked for this, actually I worked for at one point for 2 Dutch international chemical companies, which means I made it to Netherlands and Europe a lot. In fact, one of the companies, when I'd go there, and this was in the late 80s or middle 80s, that's a while ago, into the 90s, when I'd go there, I'd stay in Europe anywhere from 2 to 4 weeks. After you've done it a couple of times, at the end of 4 weeks, you're glad to be back in your own bed. But it was fun because I was, as a senior manager, put up in good places. Well, when I'd go there, and I'd be in different cities, like Manchester, England, in the Netherlands, I'd be in Gouda, or The Hague, Den Haag. I get postcards, and people in my research group, and I had a large research group I managed, and friends and relatives, I'd send postcards, having a great time, wish you were here. Next city, having a great time, glad you're not here. But anyways, they'll enjoy getting my postcards. Now, if you send a postcard to someone and you put their name, their street address, and their city, state, and zip code, will they get that card? Probably not, because you need either their house number, apartment number, condo number. Well, organic molecules are the same way. And the question is, what carbon is the ethyl group on? And the IUPAC rule is you start from the end. You start from the end and number. Now, listen carefully. Common mistake students make on test 1. And I'm telling you this so you don't make that common mistake. They say, oh, the ethyl group is here, and they say that's carbon 1. No, you can only have carbon 1 at one of the ends of the chain. And you determine which end by which one gives the alkyl groups the lowest number. If I start from this end, in red, the ethyl group is carbon 6. In black, it's carbon 4. In IUPAC rules, you use the lowest number. And therefore, that would be 4-ethyl nonane. Let's go through how we did this again. We found the longest chain. That's our root name, 9 carbons. Remember, I have to number and check all the possible chains. And we looked at the table, and 9-carbon alkane is nonane. Then we looked at what was left over, 2 carbons. And we went to the alkyl group table. 2 carbons is called ethyl. And then what carbon is the ethyl group on? And that is, you number from the ends. Remember, not anywhere else do you start numbering. And that was on carbon 4. So it's 4-ethyl nonane. And that's how you do it. Oh, let's do one more. These are fun. All right, I'm going to take you through stepwise. And the first thing I ask you to do, what's the longest chain? How many carbons are in the longest chain? Oh, tonight at midnight, I'll be giving speed structure drawing lessons. No, I won't. All right. I can also do this one. Give me a thumbs up if you're done. What's the longest chain? I think everybody's done. So let's take a look at this. If we go across 1, 2, 3, we start here 1, 2, 3, or start here 1, 2, 3. So any way you count, the longest chain is 3. And I'm going to show you this, which you're going to memorize. What's the name for an alkane with 3 carbons? I see someone said that. You're right. 3 carbons. You've learned this chain, this table, propane. So the root name is propane. As soon as you say that, there are 3 different ways I can circle 3 carbons. They're all the same. You'll get the same answer. I'll do this. Now, am I done? No, this is left over. Now, what do we call a 1-carbon alkyl group? Your turn to find it on that table. CH3, what's its name? Time's up. Hopefully all pick methyl group. So CH3, the alkyl group, a substituent, is methyl. Now, what carbon is it on? I'm going to let you try and figure that out. Am I nice, sharing the fun, or not? Don't answer that. Again, all I'm asking you, what carbon is the methyl group on? Yeah, it looks like everybody's done. So it's my turn. Now I can say this is carbon 1, 2, 3. Or I can go the other way. 1, 2, 3. So either way is on carbon 2. So how do we indicate that? 2-methyl propane. Now, there are cases when you have 2 or more identical groups attached to the main chain. And when this is true, we use prefix, and I'll show you, di and tri. You know, something I've never used tetra. What does this mean? So if you have 2 or more of the same group, we use things like di for 2 groups as a prefix, and I'll show you how to do this. Tri, 3, and I've never used tetra, other than a really bad joke that I'm not going to spring on you because it's really bad. But let's take a look how to do this. Again, the same question. Give the IUPAC name for the following. Remember, 50 points out of 100 on test 1 will be these type of questions, nomenclature. There are 2 main ones. Here's the structure. Give the IUPAC, which means the official name. So the first thing I'm going to let you try first is, what's the longest chain? Didn't know I'd be using your brain in climate class. See how mean I am? I'm making you think. Again, all I'm asking you to do is, what's the longest chain? Boy, is that a pretty molecule. Now you know I'm an organic chemist. All right. All right, I think everybody's done. What's the longest chain? Well, we can go 1, 2, 3, 4. We can do 1, 2, 3. We can do, and I'll write this one out. 1, 2, 3, 4. We can also do 1, 2, 3, 4, and 1, 2, 3. So of all the chains, the longest chain is 4. Now you can pick any one of the 4 carbon chains, you'll still get the same name. That's the beauty of IUPAC. Well, let's pick this one. 4 carbons is butane. In case you think I'm not telling you the truth, let's look at the table. You should know. I got it right. 4 carbons is butane. By the way, I know this as fast as I know my first name, and by next weekend of it, you should know this table as well as you know your first name. And I'm assuming all of you know your first name like that. So are we done? No, I have not only 1, but 2 alkyl groups. And what's CH3? It's soon to be your good buddy, your good friend, the methyl group, CH3 methyl, CH3 methyl. Now, we have not 1, but 2 of them. And remember, we used the prefix di for 2 groups. Tri for 3 groups. And I won't put down tetra because I've never seen it other than in a bad joke. So I'm not going to even do that. So 2 methyl groups is, watch this, dimethyl. One of the bad things when you're writing on a whiteboard or this is give yourself enough room. So that would be dimethyl. Now, when you have 2 groups that are the same, you need 2 numbers. When you have 3 groups that are the same, you need 3 numbers. Even if they're on the same carbon, you need 3 numbers. For tri, for di, I need 2 numbers. How do you number it? You number it from the end carbon and give the overall, the alkyl groups, the lowest number. Well, if I start on the top in black, 1 methyl group is on carbon 2, the other is on carbon 3. And this happens a lot in organic chemistry. If I number the other way, same thing. 1 carbon is on 2 methyl group, 1 is on 3. So how do you show that? When you have more than 1 number, use a comma, 2, 3 dash dimethylbutane. So let's go through, how do we do this? We found the longest chain, 4 carbons. Next, we said, what's the name of 4 carbons? And we learn, you learn, I already know this, 4 carbons is butane. So the base name, root name is butane. Next, once those are spoken for, that's why I drew a circle around it so you can see what's left over. I have 2 methyl groups or 2 alkyl groups. And what's the name of a CH3 alkyl group? CH3 attached to something is a methyl group. But when there's more than 1, we use prefix 2 as di, 3 as tri. So it's dimethyl. And then each methyl group, you have to assign the lowest number, and you start from the ends. Now, common mistake on test 1, I'm telling you this, students will call that carbon 2 1, and it'll be wrong. And I'll mark it wrong. So please don't do that. You can only have from the ends carbon number 1. And that's how you do it. And if you had longer chains than other alkyl groups, we'll do that. Now, there's another type of nomenclature question, which we did already, but let's look at it. Well, one thing I neglect to mention, as you know, there's no such thing as a dumb question in my class. If I ever write anything on the screen here and you can't make it out, ask me, what the heck did you just write? Or something more polite. And I will always clarify it, always. Again, multiple part, I never give multiple choice. Oops. One bad habit I have, I start drawing structures when I should draw. So the question is, draw the structure for 2-methylbutane. Well, how do you do that? Watch closely. How do you decode this with that secret code to know what to draw? You always start from the right and move left. You start from the right and move left. And the first thing we see, the root name butane. So we say butane, wait a second, or 2 seconds. I've learned this chart. Butane is 4 carbons. So I know the root name, butane, I'm going to draw 4 carbons. Now, word to the wise, or word to everybody, put in your hydrogens at the very end. Don't do them now, because you'll wind up erasing them. All right, so are we done? Now, as we move this way, we have a methyl group. And what's methyl group? Oh, I've learned this table. And methyl group, soon to be your good friend, is CH3. So I have a methyl group, and where do we put that? Well, it's on carbon 2. So I'm going to start here. This is 1, this is 2. And I'll put my methyl group. And now I know there are 4 bonds to carbon. And I can put in my hydrogens. And that's how you do it. Let's go through this again. You start from the end, the right, and you move left. Butane, 4 carbons. I drew my 4 carbons. Then I have a methyl group, which is on carbon 2. And if I start this way, that's carbon 2. But now you're going to say, Dr. White, what if I said this is carbon 1, this is 2? And here I'll call this structure 1 and structure 2. Are those different? And the answer is no, they're the same. Now, people tend to forget molecules are not flat and glued to a piece of paper or screen. Just like my hand, they move around in 3 dimensions. By the way, how many of you thought of if you were out today and felt the wind or over the weekend, those are molecules of oxygen, nitrogen hitting you in the face. That's chemistry too, but not organic. Well, anyways, If we take structure 1 and think of it like my hand here, if I were to tell you close your eyes, while your eyes were closed, I did this, I'd say, oh, look, open your eyes, it's something new. You'd say, oh, come on, you just rotated your hand 180 degrees. Well, going from 1 to 2, I've rotated 180 degrees. Here's the molecule that I have there. Carbon 1, carbon 2, my methyl group. And if I rotate it here, carbon 1, carbon 2. So these are the same. All I've done is rotate that molecule 180 degrees. So on a test, which one is the correct answer? And the answer is either one, because they're the same molecule. And luckily you have an instructor, me, who has a piece of paper signed by the Board of Regents of Michigan State University. I understand this stuff. In other words, my PhD in synthetic organic chemistry. All right, let's go through it again. You start at the end, butane, 4 carbons. You write the 4 carbons. You have a methyl group, CH3, and it's on carbon 2. And that's what you did. And don't forget, there's 4 bonds to carbon. And now it's time for you to have some fun all on your own. Let's draw the structure for 3-methyl octane. Now, in case you haven't memorized it, how many carbons in octane? Everybody see that on the screen? 8. In case you haven't learned it, which you probably haven't, methyl group is CH3. Oh, it makes my heart feel good to see everybody working on their organic chemistry. Thank you. And please be patient. I try and give everybody time to finish. Don't forget, 4 bonds to carbon. And everybody's done, so it's my turn. How do you decode this to know what to draw? Start from the right, move left. Octane, 8 carbons. 8 carbons. As I move further to the left, methyl group, that's CH3. And how do you know that? And know this, methyl CH3, that's that alkyl group. What carbon is it on? Carbon 3. So if I start here, 1, 2, 3, I can put it here. You could have started here. Most of you won't. I would, or I could. Either way would work the same. Now I know there are 4 bonds to carbon. And this is why you leave the hydrogens to last. It's easier. Remember, starting Wednesday, it's your solemn responsibility to make sure I put the right number of hydrogens in. If we look at carbon number 3, how many bonds to that? 1, 2, 3. Remember, there are 4 bonds to carbon, which means there's 1 hydrogen on there. And that's how you do it. Any questions? I've been around, I'm not going to log in. If you go to the content area in Blackboard, and let me open up from a file from my computer. You'll find the alkane problem set. Does everybody see that on your screen right now? The alkane problem. Thank you. Now, these are things you should be working on now. You're not going to learn organic chemistry a day or two before a test. Trust me, you're not going to like the results. Keep up. You should be able to do problem 1. Put in the carbons, hydrogens. Next, problem 2. Give the IUPAC name for the following. I'll give you number A, 2A. How many carbons the longest chain? 3. It's an alkane. It's propane. And then your alkyl groups. And that's how you do it. Now let's do one more. And this will be give the IUPAC name for the following. And I'll do it. And there are 10 carbons across, plus on this carbon right here, CH3, and this carbon right here, CH2, CH3. And I'll be patient while you're all writing it down. Boy, I just looked at the clock. Boy, time flies when you're having fun with alkanes. All right, everybody have it written down? All right, the longest chain, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you can count 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the longest chain is 10. Let me clean this up for a second. If we were in a classroom, you'd be watching me use the eraser right now. All right, so the longest chain is 10. What do we call that? Well, you've learned this table. 10 is decane. So the root name is decane. And as soon as I say that, that's all spoken for. And now, oh, we have two different groups, methyl and ethyl. CH3 is methyl, CH2, CH3 is ethyl. How do I know that? Wrong thing. Oops. Right thing. I've learned this table. 1 carbon methyl, 2 carbons ethyl. There's 2 different 3 carbon N-propyl isopropyl. There's 2 different 4 carbon N-butyl and tert-butyl. Later on, I'll call it T-butyl. So we have a methyl and ethyl. Now, if we look at the slide, if 2 or more different types of substituents are present, they are listed alphabetically, except the prefixes di and tri are not considered when alphabetizing. So when you have 2 different groups, the group that has the highest alphabetical priority, meaning close to the front of the alphabet, get listed in front of the other ones. Now it's time for a little gift from Dr. White. I hold myself responsible for all IUPAC rules. I should. I'm a chemist, organic chemist. This one on my test, I won't hold you because it can get pretty tricky when you have N-propyl and isopropyl, and the isopropyl or N-pro. Let's do it this way: methyl and isopropyl. The isopropyl, you don't do the I, that's a P, and the methyl is an M. But I'm going to teach you the rule anyways. And so let's go back to our example. Now we have an ethyl and a methyl group. And correctly, it'll be ethyl and then methyl. Now, which carbon are they on? Each alkyl group needs a number. And you number, remember, only from the ends, and you number in such a way that the alkyl groups have the lowest numbers. So you have 2 choices. If we number in black, the methyl group is on carbon 3, and the ethyl group is on carbon 4. If we start from the right, the ethyl group is on 7, the methyl group is on 8. Which are the lower numbers? 3 and 4, 7, 8, and time's up. Hopefully you all pick 3 and 4. So how do we do that? The ethyl group is on carbon 4, and then dash, and the methyl group is on carbon 3. So it's 4 ethyl, 3 methyl, decane. Say that 5 times quickly. No, you don't have to. So let's go through what I did. I found the longest chain, 10 carbons, decane. When those 10 carbons are spoken for, what is left over? A methyl group and an ethyl group. We number in such a way that the carbons are on the lowest numbers, the alkyl groups, not carbons, alkyl groups, and that would be 3 and 4. Now, listen carefully. Don't tell the IUPAC police I'm doing this. Shh. But on a test, this is the correct IUPAC. But on a test, I would allow this right here. Remember, don't tell the IUPAC police there are no IUPAC police. But anyways, I'm not going to hold you to the alphabet rule because it can get tricky. Now, one other thing I mentioned, but let me just show you something real quick. If we look at this molecule, again, what's the IUPAC name? The longest chain, any way you count it, is 3 carbons, propane. And if I call these 3 carbons my propane, what do I have left over? 2 methyl groups. Now, here's something students get wrong, and I'm showing you the right way. No matter what way I number, both methyl groups are on carbon 2. Whenever you see di for in front of an alkyl group, that means you need 2 numbers, even though they're the same. Whenever you see di, you need 2 numbers, and therefore this would be 2,2-dimethyl. If I were, and this is wrong, if I were to write this, if I see di, if I knew one methyl group is on carbon 2, where's the other one? I don't know. And IUPAC names, you never have to guess. Never. At least I've never seen it, and I'll bet on it. And if I say I bet on it, that means I've already won. All right. Oh, if I look at the clock, it's time for a 5-minute break. I'll see you at 2:51. Let's take a 5-minute break, and we'll continue on. Time to get going. Or better yet, I'll use another whistle. Time to get going. All right, before we continue on, let me remind you, on Tuesday and Wednesday, not Thursday, Tuesday and Wednesday, from 6 to 7:15 on Zoom, I have office hours. If you have any questions, feel free to stop by. Or if you just want to say hello, stop by, because I'll be there. If we're at ECC face-to-face right after class, because I'm only on campus when I taught face-to-face Monday and Wednesday. But this way, you don't even have to drive to ECC to get help. Now, one thing, if a lot of you can't make it to that office hour, let me know, and I can change it. Now, I teach at College of DuPage, COD, in the morning, so I'm not going to have morning office hours. But if you need to, if it helps you to adjust the time, I can do that. Also, if it's just one person and you need help, let me know, and I can set up a special Zoom meeting to help you out. I don't know if I told you this, but I'm a very selfish person in certain ways. And one way I'm very selfish is I like to have things around me that make me happy. I'm very selfish that way. And one of the things that makes me really happy is to see students succeed. My students, or any student, but especially mine. Also, when you come to my office hour, like tomorrow, if nobody shows up at 6 when I start, I might be on the internet looking at things. So if you log in and see someone looking on the internet, say something, I'll have my speakers on, they're right up there, they're big and amplified, and I'll know I have a visitor. All right, as I mentioned before break, you should start working on the problems. You're not going to learn organic chemistry. Even I didn't a couple days before the test. You have to keep, well, you don't have to keep up, but if you want to do well in my class, please keep up, please. All right, let's move on. Now, in terms of punctuation, I'm not going to hold you to this, but hydrocarbon names are written as one name, like octane, etc. Numbers are separated by commas, are separated by hyphens. If you forget the hyphen, I'm not going to take off points. Don't forget the comma, because it was 2,3, and I say, oh, it's 23. No, you made it wrong. I'll take off a point. There's no space between the names, a substituent, the last, and the name. But if you put a space there, I'm not going to take off a point for that. All right, let's move on. Now, there are other substituents. We've done the alkyl groups. The halogens, I'm going to wait until we get into aromatic compounds. We've done the IUPAC. The halogens I'll teach you later, and we won't go through it now, are fluoro, chloro, bromo, iodo. And you number them just like you do the alkyl groups. All right, let's go to cycloalkanes. Now, cycloalkanes, good news, similar nomenclature. Remember, nomenclature is a fancy word for naming alkanes. Now, one thing I should remind you is that this is not the most exciting part of organic chemistry, but it's an important part, because this is how we communicate. Now, here, unlike alkanes, where you have to find the longest chain and name it, the ring portion serves as the base name. But put the prefix cyclo is used to indicate a ring. So in order to find the longest chain, you use the ring, and you use the prefix cyclo. So let's take a look at this. By the way, you'll understand why I'm writing 3 points each after first test. Hint, Remember IUPAC, and actually that's a capital I, so I shouldn't have this up there. IUPAC means the official name. I'll never ask you that. What does it stand for? Even though I like to say International Union Purified Chemistry. So the question is, give the IUPAC name for this. Well, this is a ring. And in rings, we don't show carbons or hydrogens. Mother Nature and Dr. White love rings, students don't. I don't know why, I love them. Because a number of my patents, I used rings, and also for my PhD thesis, I used rings. So you count bends in a line. 1, 2, 3, 4, 5. Remember, each bend is a carbon. I'll show you now. In the future, I won't. And each one has 2 hydrogens, because there's 4 bonds to carbon. So how do we name this? 5 carbons. You look at this table, which is why, hint, you should know this. 5 carbons is pentane. So 5 carbons is pentane. But it's a ring. And how do we show a ring in a name? Use the prefix cyclo. So this is cyclopentane. And that's how you do it. You count how many carbons in the ring, and you name that from the alkane, 5-pentane. But to show it's a ring, we use the prefix cyclo. Now, once again, common mistake on test number 1, a student will write pentane, and I'll give them 0 points. And they'll say, well, at least I got 5 carbons right. I said, if you were taking, I've never taken this. How many of you have taken anatomy and physiology, A&P? If teacher said, what's the name of this? And you say foot, do you expect to get any points? No. Oh, it's got 5 digits like my foot. It's important to use the prefix cyclo. Now, time for you to help me out. How many carbons are in this ring? All right, I think time's up. Let's find out. Every bend in a line is a carbon. 1, 2, 3, 4, 5, 6. 6 carbons. How do you name this? Well, you look at this table, 6 carbons are hexane. So part of the root name is hexane. But this is a ring. How do we denote a ring? By the prefix cyclo. So the full name is cyclohexane, and that's a 6-membered ring. I think I might have mentioned it earlier. If not, I'll do it now. In all of your hormones, otherwise known as the steroids, there are 3 6-membered rings and 1 5-membered ring. So if you're asking, why am I learning this stuff? Well, it's in your body. Ooh, that's scary. Hopefully not. All right. Now, this is not a triangle. This is a ring. What would be the IUPAC name? What's 3 carbon? Ooh, I gave it away. All right. How many carbons in the ring? Well, I just gave it away. Bad, Dr. White. And what is the 3 carbon name? Everybody see that? And now I'll let you finish up, and I'm going to be quiet. Give the IUPAC name for that molecule. All right, looks like everybody's done. So 3 carbons is propane. And it's a ring, not a triangle. We call that a ring. So you need the prefix cyclopropane. Let's do 2 more. This time I'll keep my mouth shut. First of all, you have to figure out how many carbons in a ring. That's not a square, that's a ring. And now look at this table and find it. Oh, you know what I've heard? Yep, no, it's there. The only bad thing about being on Zoom is with not everybody having their webcam on, I can't tell you when the class is done. Face to face, I can. Yeah, it looks like everybody's done. So how many carbons in the ring? Count every bend in a line. 4. 4 carbons is butane. But it's a ring, and you need the prefix cyclo, so the full name, no space, cyclobutane. Now, in real life, mostly you're going to find, like 99% of the time, molecules in our daily life with 5, 6, or 4 carbons. 3 is rare. Higher in research, yeah, but in your daily life, you're not going to see any. But there's one I'd like to do, and you don't have to write this down. And again, you don't have to write this down. Eight is octane. And it's a ring cycloalkane. You don't have to write this down. And every time I'm driving and I come to a certain sign, I think of cyclooctane. And what is that sign? Every time I come to a stop sign, oh, there's a cyclooctane ring. 8 carbons. I've never worked with cyclooctane. All right, so that's how you do a ring when it's just a simple ring. Let's look at this compound. And first, let's go back. Notice the ring portion, you put the cyclo in front of the base name. Now, if only one substituent is present, then no number is needed. When one substituent is present, no number is needed. Unlike an alkane where you do need it, a ring is different. Now, let's look at these two molecules. Let's call this number 1 and 1 from column 2. All right, we look at number 1. How many carbons in the longest in the ring? 1, 2, 3, 4, 5. It's pentane. It's a ring, cyclopentane. As soon as I say that, this is all spoken for. And what do I have left over? Oh, look, it's your good friend, the methyl group. It's methyl cyclopentane. Now, when there's only one substituent, you don't need a number because the methyl group is always going to be on carbon 1. Everybody knows that. Now, if we look at number 2, guess what? It's the same thing. You're going to say, no, that looks different. No, all I've done is rotate it. So no matter what carbon the alkyl group is on, it's always going to be carbon 1. Since we have that, when you have an alkyl group, only one on a ring, you don't use a number. Your turn. What would be the IUPAC name for the following molecule? First of all, how many carbons are in a ring? Next, hint. And by now, does everybody know what a CH3 group is called? You will in a week or so. All right, I think everybody's done. So how many carbons in the ring? 1, 2, 3, 4, 5, 6. 6 carbons is hexane. But it's a ring. Don't forget the cyclo. It's cyclohexane. Common mistake on test 1. Don't forget the cyclo. Now, as soon as I say that, this is all spoken for. What do we have left over? It's your good buddy, the methyl group. So that would be methyl cyclohexane. All right, now it's easier on rings than a long chain. Let's look at A and B. Now, here we have two rings with each one an alkyl group. Now, if we look at A, we have 1, 2, 3, 4, 5 carbons. Pentane, it's a ring. That's cyclopentane. Now, what's the alkyl group we have here? How many carbons are there? You got to count them. And the answer is 3. Notice the ring is bonded to the N carbon. So what's the name of an alkyl group with 3 carbons that's named bonded to the N carbon? Well, you've looked at this table and you've learned that 3 carbons to the N carbon is called N-propyl. So that's an N-propyl group. Again, 3 carbons to the N carbon is N-propyl. So this is an N-propyl. Now this is lowercase. And normally I do capitalize when I print, but that N is important because when we get into another area of naming later in the semester, capital N means something else. So that's always lowercase. So that would be N-propyl cyclopentane. Now, if we look at B, we also have 5 carbons ring. And that's cyclopentane. Don't forget the cyclo. Now we have this substituent. How many carbon atoms do you see? The letter C. 3. And notice that the 3 carbons connect together, it's to the center carbon. And what do we call that? Alkyl group. And here, 3 carbons connected to the center carbon is called isopropyl. So 3 carbon alkyl group is isopropyl. So this is an isopropyl group right here. So it would be isopropyl cyclopentane. And that's how you do it. Now that's with only one. That's not what I want. Now, when you have 2 or more alkyl groups, this gets a little tricky, but I'm not going to hold you to this rule, but I'm going to teach it to you. And you'll still have to master some of it. 2 or more alkyl substituent groups or alkyl groups are named and numbered the same as alkanes. Now, here's where it's different, except the alkyl group with the highest alphabetical priority is located at carbon 1. When you have 2 or more alkyl groups on a ring, the one with the highest alphabetical priority, the one located close to the front of the alphabet, is number 1. So let's take a look at this. Remember, things get exciting later on, but right now this is very important. How many of you remember? I just thought of something. How many of you remember in 1st grade when you were learning how to read? I have a photographic memory. Right now, I can close my eyes. I can picture myself when I was in first grade. I can still see that room. I can see the teacher. I can see the desk. I can see we're sitting with the reader, first grade reader. What was it? C. Jane, Dick and Jane. I don't know. They had that when you were, no, Dick and Jane and Spot. They had that when you were a little kid and you started learning. But before you learned how to say, read words, and then sentences, then paragraphs later on. And then later on in life, you learn, wow, books are fun. I was lucky my parents enjoyed reading and they passed that on to me. So how do we name this? We have a ring. It has 6 carbons. Every bend in a ring is a carbon. So that's cyclohexane. I have a methyl group and an ethyl group. And now, which of these has alphabetical priority? E. So when you number it, this is going to be carbon 1. So it'd be 1 ethyl. Now you number in the direction clockwise or counterclockwise to give the other alkyl groups the lowest number. And that would be the methyl group is on carbon 2. If we went the other direction, and the blue is wrong and you don't have to write this down, it would be on carbon 6. So which is the smallest number? 2. So the correct IUPAC name would be 1 ethyl, 2 methyl, cyclohexane. Let's go through that again. You find the root name, a ring, count the number of carbons in the ring, 6 hexane. Don't forget the cyclo. That's an L, that looks better. And then I have 2 alkyl groups on there, a methyl, CH3, ethyl, CH2CH3. Since ethyl has the highest priority, it gets number 1 and the methyl 2. However, I'm not going to hold you to this. Shh, don't tell anybody I'm being nice. Shh, please. And there are 3 other answers I'd accept for this, even though this is the correct IUPAC. And whenever I go through this or an answer on the test answer key, I will always give the IUPAC correct way. Now, if you had written 2 methyl, 1 ethyl, put the methyl in front, I would have accepted that. If you had written 2 ethyl, 1 methyl, numbers changed, I would accept that. If you switch the numbers and the names, I would accept that. If you don't get the root name right, cyclohexane, it's always going to be wrong. All right. Your turn. What would be the IUPAC name for the following molecule? Count the number of carbons in the ring. Remember, if you're having trouble, you're new at this. I remember when I was new at this, it didn't come that easily at first, and I became an organic chemist. And don't forget, if you're having problems with this, you can always come back and watch the videotape. And thanks to all of you for making me a YouTube star. All right, I think everybody's done. Let's take a look at this. How do you name it? Ooh, I've got a ring. How many carbons in the ring? 1, 2, 3, 4, 5, 6. 6, oh, somebody wrote this on top, is cyclohexane. And now, as soon as I say that, that's all spoken for. I have on the ring 2 alkyl groups. CH3 is methyl, and CH2, CH3 is ethyl. And as you've heard me say, hopefully you'll all learn as soon as possible. Well, all right, this happens once in a while, and I've got to do something. I'll be, hold on. It overloads because I've had so many things going on. I have to reopen Word again. Sorry about that. All right, we're back up to speed. I got to have more memory put in this machine. It's on order. Hopefully it'll be soon. Anyways, we have a methyl and ethyl. Now, what we need to do is first of all, clean this out. This is going to be carbon 1. Now I'm doing the right IUPAC. There are other answers you could have given. If this is 1, we go counterclockwise. The methyl group is on 3. If you went the other way, let me just show you 1, 2, 3, 4, 5. You always give the alkyl groups or any substituents the lowest number. Which is smaller, 1 and 3 or 1 and 5? Hopefully I'll pick 1 and 3. Now the correct IUPAC for this would be 1 ethyl. The methyl group is on carbon 3, 3 methyl. Yeah. That's better. 3 methyl cyclohexane. there's a little longer space there. That's okay. There technically shouldn't, but I don't grade if your space is a little more, as long as it's not on the next page when you do answers. So there are three other answers I would accept. If you have the 3-methyl first, I would accept that. If you have the numbers reversed, 3-ethyl, 1-methyl, or if you have the names and numbers reversed, that would be okay too. 1-methyl, 3-ethyl. So, but this is the correct IUPAC. Let's go through it again. The ring, 6 carbons, cyclohexane. Next, we have on there a methyl group and an ethyl group. The one with the highest alphabetical priority should be the number 1, but if you put the methyl group as 1, then you number in such a way that the other alkyl group has the lowest number, which is what you saw me do that, and that's how you do it. All right, now the other type of nomenclature question is the following. Draw the structure for this. Now, how do you do that? You start from the right and move left. Pentane, how many carbons is that? Well, you've learned this chart. Pentane is 5 carbons. And the prefix cyclo tells you it's in a ring. I think I might have mentioned cyclopentane rings always remind me of the greenhouse of the Monopoly. And when I was about 7 or 8, my sister and I used to play cutthroat Monopoly, especially when we were both homesick with a cold. When one of us got sick, the other one did too. My younger sister didn't. We were too old by the time she was born. Did I tell you I have one sister 7 years older, one 7 years younger? I'm in the middle, literally. All right, your turn. Draw the structure for cyclobutane. I'll help you out. Hopefully here this week, you're going to learn this table as well as you know your first name. While you're doing that, I can get another water bottle because I'm just about out. I'll be right back. I'm back. If we had been in a classroom right outside our classroom, there's a nice refrigerated drinking fountain. So I would have filled up my water bottle there. All right, how did you code this? Know what to draw? Start this way. Butane, 4 carbons. Prefix cyclobutane, it's a ring. You call that a square, I call that a ring. And that's how you do it. Remember, you don't show carbons or hydrogens when we draw it. All right. Why don't you try this one on your own? Draw methyl cyclopentane. If we were in a classroom, I'd have written on the whiteboards, and we got a lot in our classroom, the two tables. Unfortunately, Zoom doesn't let me put more than one thing on the screen. So I'd recommend in the future, why don't you print out or handwrite out those two tables when we do nomenclature until you learn them. Again, I'm asking you to draw the structure for methyl cyclopentane. All right, everybody's done. How do you decode this to know what to draw? You start from the right, move left. Pentane, 5 carbons. Cyclo, 5 carbons in a ring. Cyclopentane. Methyl, CH3. You could put it here. You could put it on any one of those carbons, this one. And there are 3 others I could draw. All you're doing is rotating the ring around. And that's how you do it. Oh, let's do one more. And that's 1-methyl, 4-methyl cyclohexane. Draw the structure, would be 3 points each. Draw the structure for the following molecule. And don't forget, next time you drive by a gas station, think about half the weight of the gasoline you're using are alkanes that you're buying. Or if you're not buying, whatever car you're in is using. And remember, Shell and Mobil are the best. BP is the worst. I forgot, some of the big box stores are like Costco. I don't know who they get their gas from, but it's probably one of the better manufacturers, or I should say, I guess manufacturers should work. And for those who finished early, please be patient. All right, my turn. How do you decode this? You start from the right, move left. Hexane, 6 carbons. Cyclohexane, 6 carbons in a ring. And I'm having a good cyclohexane ring drawing day. You ever heard of people say they're having a bad or good hair day? Well, I have good and bad ring drawing days. All right, next, I have a methyl group and an ethyl group. Ethyl, CH3, CH2, bond to something. Methyl, oh, it's your good friend, the methyl group, CH3. So most of you are going to call this carbon 1. Now, if you notice, I have my CH3 group on the left. You could have just as easily drawn it like this. Both are correct. Okay, but I'm not done yet. Next, on carbon 4 is my methyl group. So if I go clockwise or counterclockwise, that's 1, that's 2, that's 3, that's 4. And I have a methyl group. Now, this is one way of drawing it. There are other ways. Most of you are going to do it this way. And this is another one. There are a couple more. All I'm doing is rotating the ring. All right, like I said, nomenclature is not the most exciting part of organic chemistry, but it's important, just like you learned how to read words, and then you could read books, and then it got exciting. Organic chemistry is the same way. I would highly recommend you start doing the practice problems for the alkanes. I'll go through them in class, not all of them, but some of them, where any of you have a question. With that, I'm done for today. Remember, I have my office hour on Tuesday from 6 to 7:15 on Zoom, also Wednesday also. And this Wednesday, we'll have lecture again at 1 p.m. And soon, in a couple hours or less, I'll have today's video posted on my YouTube channel. With that, I'll say, Gehen gesund, goodbye. Remember, Gehen gesund means go in health in Yiddish. And this I stole from the Beverly Hillbillies granny. Bye now.